So what do you have right here? What do these represent right here? What are all of these? All the different rules for differentiation. These are all the different rules. You have the power rule. So if y equals ax to the n, can someone tell me what the derivative is? If y equals ax to the n, can someone tell me what the derivative is? Anybody? A n x to the and yes, the Bueller person gets an extra point. Good job. What's the derivative of the second one? Oh, come on. Y equals a to the x. Let's shake it off. Shake it off. Yep. ln a. I don't want to put parentheses around that. ln a times what? A to the x. And it's ln a times a to the x. The a to the x is not power. Yep. What about e to the x? What's that? What's the derivative of that? Yeah, it's e to the x, and there's an ln e. But what is ln e? 1, right? So it's just e. I just want to put it there so you remember. What about this? What rule? What's this one called? When you have f of x times g of x and you take the derivative, that would be the product rule, right? It's a product. So what is it going to be? I like doing it f prime x times g of x plus what? F of x, g prime of x. I like keeping them in the same order. It helps me. You can do them in different orders. Like you could go gf prime and g prime f if you wanted to. That's fine. Just be consistent. I like doing it this way. It's easier for me to see it if people are more consistent. What rule is this called? What about this one? The quotient rule. Nice. And do you remember that low d high minus high d low over low squared? So it's low times f prime minus high d low all over what? Low squared. Like that. And now what do you have to also remember? We added two things in. We investigated these before break. We investigated these two before break. Do you remember what they're called or what they are? Derivative of sine is? Anybody remember? Just take a guess. Nope. Cosine. Mm-hmm. The derivative of sine is cosine. What's the derivative of cosine though? Close. It's negative sine. The derivative of sine is cosine and the derivative of cosine is negative sine. These are the derivative rules that we've learned so far. One thing I've mentioned though is there are 4 other trig functions. What are the other 4 basic trig functions? Tangent, cotangent, cosecant, and secant. There's 4 other ones, right? Those 4 trig functions are made up of what? Sine and cosine, right? So can you use the other trig rules, trig derivatives to find those derivatives? Yeah, we'll do those later, but you absolutely can. So for example, what is tangent? Tangent is equal to sine over cosine. So you could use the quotient rule on sine over cosine to find the derivative of tangent. You can do that. You will. And you will just memorize those. So basically, there are 4 more that we'll do shortly, and those are for the basic trig derivatives. You have to memorize those. Okay. So let's just do a little bit of practice here. Here are 4. Constant is what? Nothing. So it goes away. But you're missing something here. Can anybody tell me what he's missing? Yeah, what's he missing? 5. A 5 because of the chain rule. So what's the outer function? Cosine is the outer function. What's the inner function? 5x. So what gets kicked out? A 5. And I like putting it on the front. So the simple version of this, let's say you had h of x is equal to sine of any constant times x. What's the derivative of that going to be? A cosine ax. Remember that? It kicks out the constant. It kicks out the constant. I'll erase that just so it's clear right there. What about this one? Can someone tell me what the derivative of g of x is on the bottom left? Yes?
Negative 8 sine 4x.
G prime of x is negative 8 sine of 4x. Why is it 8? Why did it become 8?
Because it multiplies by 2.
To 2. So the 4 gets kicked out because of the chain rule. The 2 is already there. But what's the derivative of cosine? What's the derivative of cosine? Negative sine. So it's negative 8. Oh, okay. This is hard to see. It says a half right there. Anybody want to tell me what this is? Someone who hasn't spoken yet? Yeah, go ahead.
So
yep.
5 over 2 cosine.
Yeah, 5 over 2. What is it?
Cosine.
Of?
1/2 x.
Yeah, also x over 2. And is it plus 6?
No.
No, because the derivative of constant is 0. Rule, which you haven't finished yet. There's 2 functions here. There's this function and that function. There's 2 functions. There's the first function and the second function. What's the derivative of the first? Yeah, so it's going to be e to the x cosine 2x plus, now what's the derivative of this? Now it's the function itself times the derivative of cosine 2x. What is the derivative of cosine 2x? Negative sine of what? Times doing the derivative of
times e to the x again.
well, the e to the x is already there, but if you're doing the derivative of cosine 2x, it's going to be negative sine of 2x times what? What's the inner function? 2x. What's the derivative of 2x? 2. So right there. So if you clean this up a little bit, it would be e to the x cosine 2x minus 2e to the x sine of 2x. That would be a nice way to write it right there. This function right here, what's the derivative of cosine 2x? There's the derivative right there. There's the derivative. What's nice about e to the x? Well, what's the derivative of e to the x? Itself. Itself. Over here, right here, you see this over here? There's two functions, 3x squared and sine of 1/2 x. 3x squared and sine of 1/2 x. Gabby, what's the derivative of the first function?
6x.
So f prime is going to be the derivative of the first times the second plus the first times the derivative of the second. Can you tell me what the derivative of the second is?
1/2
1/2 cosine of 1/2 x. Exactly. Why is that 1/2 there? Because what's the derivative of 1/2 x? What's the derivative of 1/2 x? 1/2. So if you cleaned it up a little bit, you could clean it up as, if you wanted to, half x plus 3 over 2 x squared cosine of 1/2 x. I actually, remember how I've said at the beginning, I really like you to just kind of leave it like that. Why do I like you leaving it like that? Anybody remember? Yeah.
Because it's really easy to see like where we got our parts
Exactly. It's where did you get your parts from? I'm much more interested in knowing that you got the parts, because then I have to track down how you combine fractions and things like that. Like 3 over, oh, there's the 1/2, right? It gets worse. It is, some of you got it right off the bat or got really close, which was great. In this case, g prime of x is equal to, kids, we're back. G prime of x is going to be equal to, yeah, it's ln 4 times 4 to this thing, 2 sine 3x, but then you have to multiply by the inner function, the derivative of the inner function. In this case, the inner function is 2 sine 3x. What's the derivative of 2 sine 3x? 6 cosine 3x. Correct.
Can you just leave it all together instead of separating ln 4 times 4?
I mean, with the parentheses I put in?
Yeah.
Thank you. Thank you. Yeah, you could. Absolutely. Sure. You could. I like putting the parentheses in because it shows me the 3 sections. What about over here? What does that sign with the 3 mean? That means sine of t all to the 3rd power. So if something is raised all to the 3rd power, what can you do with that power? What can you do with that power?
Bring it down.
Bring it to the front. So h prime of t is going to be 3 times sine of t to the what power?
Second.
If you bring the 3 down to the front, second, but then you have to multiply by the derivative of the inside. What's the derivative of sine? Yep. And you're done. And you're done. On the second one right here, what rule do you have to use? What's the overarching rule? Yeah, the derivative of the first is going to be e to the x. And then you have the first times the derivative of the second. What's the derivative of the second? ln 7, 7 to the x. Yeah? When you practice these, kids, when you practice these, you are soon going to get to the point where everyone we've done in class today, you'll just be able to do it almost as fast as you can write. I firmly believe you will get there. And a sheet like this in a week or two or less, you're going to be able to do just as fast as I can, which is just as fast as you can write. The rules will kind of get inculcated, like imprinted on you. Okay, so let's see what you can do by yourself. Try K and L by your, get a little bit more entertaining. Now, this 3, what can you do with this 3 to make your life easier? It's just what? It's just along for the ride. The 3 is just along for the ride. So you can keep it in the front and do nothing else with it. Just keep it at the front. So this 3, let's just leave it right there. So y prime is going to be 3 times, well, you have e to that thing. So we know we start with ln of e times e to that thing. But then what do we have to multiply by? Oh, it's cubed. Thank you. Yes. But then what do we have to multiply by? We just did one like this to start the class. The derivative of the power. What's the derivative of the power in this case? 3 times
5x plus 3
squared times what? 5. This right here, what's the derivative of that? The derivative of that is right there. There's the derivative right there. What did you have to use twice when you did the derivative there? Well, not twice. You had to use the power rule, but then the 5 gets kicked out because of the chain rule. The 5 gets kicked out because of the chain rule. Well, this way, I could say this right here. This, there's the derivative. So
So you're doing them both separate. You're doing the 5x plus 3 to the third derivative, and then just the 5x plus 3.
yes,
And then
as
you're-
part of it,
yeah.
inside, I'm to do this derivative. To do this derivative, it's using the chain rule, right? And the chain rule says you do the outer derivative. What's the outer function? The outer function is something to the third.
Yeah.
What's the derivative of something to the third? That's 3 times something squared.
Yeah.
But then what's the derivative of the something?
Yeah.
The 5.
I'm with
So
you.
we're doing the derivative inside each other. Calling it the chain rule. Calling it the chain rule. What is cotangent? What is cotangent?
1 over tangent.
Yeah, so that's going to be cosine x over sine x. So when you do this out, when you do the derivative, low d high minus high d low, low d high, what's the derivative of the high? Negative sine, low d high minus high d low, which is that right there, all over what? Low squared. So what do you end up with here? Negative sine squared x minus cosine squared x all over sine squared x. What can you factor out of the top? Negative 1. So you have negative sine squared x plus what? Cosine squared x all over sine squared x, right? What's cosine squared plus sine squared, everybody? So you have negative 1 over sine squared. What's 1 over sine? What's 1 over sine? Cosecant. So this is negative cosecant squared x. So there's something for you. The derivative of cotangent is what? Negative cosecant of squared x. Yay! Super cool. I know you're just over the moon thrilled about this. I know. So do you want to complete the 6 just for fun? So what are the other 2 that we have to do? We haven't done the derivative of what? Yeah, correct. So see if you can by yourself. Let's say h of x was secant x, and this was, I don't know, n of x was cosecant x. See if you can figure out how to find the derivative of both of those. Try that. Try that. Let's just complete x to the what power? Negative 1. So what can we do now? What can I do? Can I differentiate now? Yeah. What can I drop to the front? What can I drop to the front? Negative 1. So h prime of x is going to be negative cosine of x to the what power?
Negative 2.
Negative 2. And what's the derivative of cosine? Negative sine. Let's take a look at this. Take a look at that one first, everyone. Do the same type of work to this one. I just gave you a